Okay, so our next example of differential equations, this is video number 4, is looking at finding the particular solution to this differential equation here. You possibly can't see it, there we go. So that's the question. Find the particular solution to the differential equation, given that x is 1 and y is 4. Now I'm going to go through this one not because it requires any additional or any particularly different steps, but simply because it's an integral that we haven't done as part of a differential equations question, and it is a particular favourite, this method, of examiners, so you possibly will see lots of past exam questions that look like this. So I've also removed the steps from the side, which is just to give us all a little bit more space. So I'm going to split my page in half in an attempt to get all the working out onto one page. So as I'm reading the question, I am noticing that I've got just one bracket with y terms on as on the numerator of the expression. Everything else is in terms of x. And I'm also noticing that I've got those boundary conditions here, which is helpful because I am being asked to find that particular solution. So let's remember our method. We do separate, we do integrate, then I choose to do evaluate before manipulate. You can do it the other way around, but we're going to go separate, integrate, evaluate, manipulate. Okay, there is a step 5, but we will come to that. So number 1, step 1, separate. Okay, so I need to keep the y's on the left, which means I'm going to take the y over 2, which is in a bracket, and have to divide by that. So that's 1 over y minus 2 dy onto the left. On the right, then that gives me minus 3 over 2x plus 1 and x plus 2 dx. That's a separate, and we've talked about before the fact that we should have our integration symbols there. Okay, so now we actually need to think about how on earth we're going to do that integration. Looking at it, the left-hand side is a standard integral. I know I can use the natural logarithm to do that. The right-hand side, though, is a little bit more tricky because I've got not a linear factor on the bottom. I've got 2 linear factors rather than just 1. So I am going to have to use partial fractions to split that up on the right hand side. Now I am fairly short of space, so you're going to have to trust me in this next step. I'm just going to write down what you get on the right hand side when you've done the partial fractions, as that is something that I know that everyone can do. Okay, notice I haven't changed anything on the left. We've said before, you can't integrate one side but not the other. Let's do it all at the same point. Okay, so if I split that into partial fractions, I actually get 1 over x plus 2, and I get minus 2 over 2x plus 1 with respect to x. Okay, so that's our step 1, and actually I've kind of started step 2 there, haven't I? Because I'm looking at how I'm going to integrate that expression. Okay, that is now something that I can do as an integration. I can integrate the left hand side. I've got 2 separate terms on the right hand side, both of which I can integrate. So let's go ahead and do that. We are going to have, let's see if I can fit it on one line, ln of y minus 2. Over here I've got ln of x plus 2, and then I would have minus 2 times a half of the natural log. So the minus 2 and the half cancel out, so I'm just going to go for minus ln 2x plus 1. Am I going to squeeze it in? Possibly. Then I need my constant of integration. We've seen before it makes sense for me to write that as ln k rather than plus c. Okay, now again you've got a bit of a choice. We can whack our boundary conditions in right now. We can do a little bit of manipulation first. I am a fan of getting straight down to the evaluation and subbing in that x is 1 and y is 4. I just think it makes the manipulation a little bit easier. Okay, so if I sub in that y is 4 and x is 1, I get ln 4 minus 2 is 2. I don't need the modular symbol because the modulus of 2 is 2. Okay, this is going to give me ln 2 as well. Oh, hang on a minute. Sorry, ln 3. Okay. Then I've got, that's a bit messy, never mind, ln of 3 again, and then I've got ln k. Okay, now maybe you can, maybe you can't see, those two cancel out, so we get that ln k is ln 2. Okay, and that then makes our expression, so going back to the line above, so this line here, and I'm going to sub in, instead of it saying ln k on the end, it's going to say ln 2. So we get ln mod y minus 2 equals ln mod x plus 2 minus ln mod 2x plus 1, plus 1, and then I've got plus ln 2. Wonderful. So separate, integrate, evaluate. We are almost there. Now it's all about making this y equals. So this is step 4. This is my manipulate, which remember is the same as just rearranging. Okay, and we're going to use our lovely log rules in order to do this. So the left hand side I'm going to keep as it is. Not much I can do with that for the moment. Okay. On the right hand side, I am going to use my log laws. So where you have logarithms that are added together, i.e. that one and that one, we can make that multiplied. So 2 times x plus 2. Okay, and then where you've got the logarithm that's subtracted, so that one, that becomes the division. So 2x plus 1. And the benefit of that is I now have a single logarithm on both sides, because remember the aim of the game is to make this y equals, so we need to get rid of that natural log, which we do by taking the exponential of both sides. Okay, take exponential of both sides. So that then becomes y minus 2 is 2x plus 2, 2x plus 1, and then I just simply add the 2 to the other side. Okay, like that. I could combine that, make that a single fraction by writing that 2 as 4x plus 2 over 2x plus 1, so common denominator, but I'm actually just going to leave it like that for the moment. Okay, so that does take us up to step 5, which I think is particularly important in a question like this. Happily, step 5 also rhymes. So step 1 is separate, step 2 is integrate, step 3 evaluate, then manipulate, although you can do them the other way around. Separate, integrate, evaluate, manipulate. Step 5 is to celebrate, because that's a pretty tricky question.